holes. So I'm going to have an N-channel MOSFET where source and drain regions are fabricated into an N plus region. N region is electrons, N plus means more number of electrons. It is even more heavily doped. Then gate, you see, it is a metal oxide semiconductor. Gate is fabricated over a P substrate. Over that you have a SiO2 layer. Over that you have a metallic layer. The gate was once made of metal, now it is made of polysilicon, where the bulk is made of P-type. So over the P substrate, I'm going to grow the entire device for MOSFET. The substrate forms the fourth terminal. Usually, you will have only three terminals, but this substrate, we leave it open because it does not have any connection. We leave the substrate to be open whenever we are going to use this device for applications. Okay. So substrate is the same potential as the source unless it otherwise. So substrate and source, it is just like see, they are short circuited. So whatever you connect here, everything is short circuited. So whatever is potential you're giving at source, substrate will also have the same potential. It's just like short circuited, but that need not be done explicitly in the circuits. You can leave the substrate from connection. Even then, your circuit is going to work. So when I'm going to apply a positive voltage to the gate, when I'm going to apply positive voltage to the gate, so definitely the opposite charges are induced, because one side of capacitor, if it is going to be positive, the other side has to be negative, because opposite charges will attract each other, right? So holes in the other side are repelled away and the electrons are attracted towards the surface of the substrate. That's what I've shown here. When I'm going to apply a large positive voltage to the gate, holes are repelled away, electrons will be attracted towards the hole, and electrons form the top electrons form a layer at the top of your substrate. At some particular voltage, the surface becomes completely depleted of charges. At a very large positive voltage, all holes will be completely eliminated and only electrons will be present in the substrate, top of substrate. Further increase in gate voltage will induce an inversion region composed of electrons. That's for you. When you further increase the gate voltage, the channel formation happens and MOSFET starts conducting. So slowly, when you increase the gate voltage, the holes are completely repelled away. At one particular voltage, there are zero holes, and once there are zero holes and lot of electrons, there is a path for the drain current to flow, and there is a channel existing between the source and drain. The channel is the conductive path, what it is to mention here.